Hello guys, and welcome to a new episode of The Post-Apocalyptic Inventor. This is a repair marathon video in which I will show vintage audio repairs and a little something extra at the end of the video. And the first device in need of repair is this stereo system built around 1977 by the German audio equipment manufacturer SABA, which is short for Schwarzwälder Apparatebauanstalt, which means as much as the Black Forest Manufacturing Institute for Electronic Devices. Well, now you know why they have an abbreviation for that. And there actually is a film from the 1950s on YouTube that shows how vacuum tube radios were made at the SABA plant back in the day. Well, but we're in the late 70s and the age of the vacuum tube radio is long over. But what was kind of typical for this time are these record player, cassette tape, multi-band radio and amplifier combination devices that were designed as a kind of console, with most of the controls installed on the top instead of on a front panel. And while this stereo system was manufactured and sold by SABA, the turntable was made by Dual, another German audio manufacturer from that same region in Germany. And why is that? Well, Dual really dominated the record player market in the 70s, and companies like Grundig, Vega and SABA usually just bought Dual turntables and integrated them into their systems instead of making their own record players. And here in the middle we have the cassette player, and on the right hand side the radio and various controls. And let me explain this here in a little more detail. So this is the radio receiver, and over here we can select between the different modes of operation. Phono is for the turntable, band is for playing the cassette tape player, U is for ultra shortwave, that's FM radio, and then we have three frequency ranges for AM radio. K is kurz, short, shortwave, middle wave, long wave. Now these three would be extremely rare these days because most of the stations have actually been demolished, but on here we can still see the names of various German and international stations that, well, would have been possible at some point in time to be received by this receiver. Normally today would only use frequency modulated stations in the ultra shortwave range. But we also have this series of buttons and little scales down here, and this is what is known as a preomat or preomat. When pushing this little button saying U/automatic, the normal tuner knob and the large scale can be used to tune into a station. But there are 5 more buttons that include a switch and a potentiometer, and they can be used to store 5 different radio stations between around 88 and 104 megahertz. And these stations can be selected by pushing these buttons 1 to 5, disabling the big tuner knob at the same time. This is the radio frequency section of the circuit diagram of the stereo system. And the preomat can be found up here. And as you can see, it consists essentially of 6 switches and potentiometers. Some might wonder now how a frequency can be adjusted with a variable resistor instead of a variable capacitor, and the answer to that is this component over here, BB103, and that is a varicap diode or variable capacitance diode, in German Kapazitätsdiode, and it can be used as a voltage controlled variable capacitor and can hence be adjusted with simple voltage dividers consisting of potentiometers. And these types of circuits can be found in many radios as well as TVs of the 70s and 80s. Now a few things about dual turntables. This little pin here in the middle can be taken out because you can put a Wechselstange, a changer axle, or that's how I would translate that in there, that can be used to play several records in a row. They would be stacked on here onto that axle, but I don't have one at hand right now. And you have these rather weird looking screws here, and they are to get this chassis out of the enclosure, and they also can be used in order to fasten the entire turntable when you move it around. You do that by turning these screws to the right until you can't turn them any further. So now it is no longer moving freely on those springs underneath, but it's like fastened to this frame. You can get them loose again, but by just screwing them right all the way until they are fixed again. Okay, and if you want to take this entire thing out, you have to again unbolt them, but only a little bit, and now you can see that they can be moved around. They're freely jiggling around. And this is something, well, you just have to try that in order to get it just right. That's how you can take out a dual turntable. And because I have to access the PCBs underneath, I have to remove the record player from the stereo system for now. And that is why I unplugged the power cord, as well as these signal wires and this ground connection. And since these wires can now move around freely inside the enclosure, potentially touching conductive paths, I use some tape to provide additional insulation. Normally I would use proper electrician's tape, but I just ran out of that. And once again, a word of warning from this point on, I'm working on a mains powered device that for at least some of the things that I'm going to do needs to stay plugged in for some of the time. This is dangerous and requires absolute focus and should not be done by people who are not absolutely certain how they can avoid being shocked. Okay, so what actually needs to be repaired here? Well, this stereo system belongs to a good friend of mine and she inherited from a relative years ago. But recently one of the two channels wouldn't work anymore, so she asked me for help. And in order to test what is actually going on, I will now connect my smartphone to the old input for reel-to-reel tape recorders. With German audio equipment from before the early 80s, this usually requires DIN 5-pole connectors as well as DIN loudspeaker plugs. 3.5mm headphone jack, 2 RCA, 2 DIN 5-pole. And after plugging the phone into the reel-to-reel input, I also connected the two loudspeaker boxes to the front left and front right loudspeaker outputs. The dual channel oscilloscope displays the voltages across the two loudspeakers. When doing this, it is absolutely necessary to know that both the oscilloscope and the amplifier have two channels, but that both of them have a common ground. Make sure to connect only ground to ground, or you might short circuit one of the amplifier's outputs. Also, check if the power amplifier uses the BTL or bridge-tied load topology, as it is common in car radios. In that case, you also shouldn't connect a dual channel oscilloscope with common ground to the amp's outputs. So here we can clearly see that one of the two channels, in this case the right one, is much quieter than the other one, and we can also see that it is not even sinusoidal in shape, but that only one of the half waves seems to be present, and that hints in the direction that most probably the outermost stage of the power amplifier is malfunctioning. But it is still connected to a preamplifier that might also be faulty, and there might also be connection problems in the connectors leading to the amplifier. Also, the power supply could be faulty in a way. So what I'm doing now is to isolate the power amplifier, and in this case, since this entire stereo system is built in a modularized way, I can just take out the entire power amplifier board from inside the enclosure. And I'm now connecting temporarily a couple of power wires to the inputs. That's for plus and minus 19 volts and ground, and that will be connected to a symmetrical lab power supply. And then of course we need wires leading to our loudspeakers and, well, signal wires leading to the left and right channel input. This lab power supply powers the power amp with plus and minus about 20 volts. These two loudspeakers are connected to the loudspeaker outputs. And also these thin measuring lines here go to the two channels of the oscilloscope. And, well, we use the smartphone again as our sound source. This time we have to go quite low in the volume. So the idea here now really is to trace the signal through the different stages of the amplifier. I start at the very input, you know, where the output of the smartphone is actually connected, to see if the signal even reaches the PCB. And you can do that at this capacitor here, for example. That's for the right channel, that's the working one. I now activate the signal, and there we have our sine wave. I don't know if you can see it very well. There it is. And now we can do the same thing with the left channel. That would be here. See? Let me zoom in again. So that signal is present. And what I'm doing now, let me pause this for a second. What I'm doing now is to basically use this probe here to trace through the different stages. You can orient yourself by the different transistors, for example. You can then look that up in the circuit diagram, and then you just more or less circle the place where the signal stops being shown on the screen. And I proceeded as explained, and could confirm what I had guessed earlier. The problem was with one of the power transistors in the final stage, in that it didn't even have any supply voltage. How can that be? Well, see, this fuse over here, which I had inspected only visually before, was blown, as you can see here in the close-up. I should have been more diligent and should have checked the fuse with a continuity tester before. That the fuse is blown, though, means that at some point the current flowing there was way too high, and there must be a cause for that. And that's why just replacing the fuse would normally not be a real solution. But the power amp is connected to a lab power supply with overcurrent limiting right now. Therefore, I think it is safe to just replace the fuse and then try to find the reason for the fault. And with the fuse replaced, the two amplifiers worked again. But there must be a reason why the fuse burned through in the first place. So I let the amplifier run a little bit, and then I noticed that the left side of the heatsink got way hotter than the right one, even when the amplifier wasn't really active. And that told me that the quiescent current on the left channel, in German der Ruhestrom, was probably way too high. And you can determine that by measuring the voltage across one of these power resistors here. And we can clearly see that it must be way higher on the left side than on the right side. I measured about 15 millivolts on the right and 150 millivolts on the left channel. While according to the service manual, there should be a voltage drop of only 20 millivolts here. And that extremely high current, combined with additional current flowing when listening to loud music, must have blown the fuse, I guess. And on these boards you will then typically find little trim pots that can be used to set the quiescent current. But even on the lowest possible setting, the current was still too high. So what could I do now? Well, one thing that you might have noticed, I already replaced all the old electrolytic capacitors on the board. But they were not at fault here at all. All capacitors had low ESR and sufficient capacitance. I figured that over the years maybe a drift of the working point within the transistors themselves might have occurred. And since I didn't have any replacement types for the semiconductors, I decided to simply somewhat reduce the value of the resistor here from 680 to 470 ohms. Now I was able to set the voltage drop to around 15 to 20 millivolts easily. After this, I tested the amplifier for many hours without having any problems, or any overheating or increase in the measured voltage. I'm normally very careful when it comes to changing the original circuit diagram, but this stereo system is over at my friend's house who lives nearby and I often visit. So I will simply keep an eye on the performance of this amplifier, and when anything should happen to it, I will be there to take different measures. After doing this, I put everything back together, I tested the amplifier, record player, tape deck and radio, and did not encounter any other problems. But this wouldn't be a proper repair marathon if I took care of only one device, and that's why we'll take a brief look at something else. This is an Acoustimass 3 active subwoofer system manufactured at around 1990, and I recently picked it up from the streets. And greetings to my viewers in Massachusetts, by the way. A visual inspection showed me that it was very dirty and that it had some physical damage on the loudspeaker clamps, and I decided to take care of that and test the subwoofer. I opened the enclosure and removed most of the nasty dust with my compressor. This part was so dirty that I actually had to submerge it in concentrated soapy water. The heatsink holding all the power transistors was also in a lousy state, extremely dirty, and with the old thermal compound all dried up and patchy. Several of these little levers of the loudspeaker clamps had broken off, so I desoldered the old one and sifted through older scavenged parts and found pretty much an exact replacement that I must have salvaged about 15 years ago from some unnamed amplifier. I then removed the old thermal compound and applied new one, and I put the subwoofer back together after the parts had dried. The enclosure had some spots where the old black paint was missing, so I took some rather desperate measures that some of you will certainly laugh at, but in my opinion it's good enough for something that I just took from the garbage. Now the time had come to test the subwoofer. I connected my phone and nothing but silence. So maybe this thing is broken, but I couldn't find any technical information or circuit diagrams online. But what I'm actually suspecting is that the subwoofer is physically okay, but that it will not put out anything if there's nothing connected to this green jack here that seems to switch on the unit and then is also used to control the volume, I believe. But until now I found nothing on this part and I have no idea what kind of signal it needs. So maybe one of you guys just knows what to do or has the schematic, then please contact me under inventordonations@gmail.com. Well, but we can't end a video with a defeat, right? And that's why I have something else for you here. This is an old Nintendo GameCube. In my opinion, one of the best gaming consoles ever made. Unfortunately, it was in a household with heavy smokers and also saw a lot of heat and sunlight, so that the once bright gray plastic cover has prematurely aged and yellowed. So what can we do about that? Well, it's called retro brighting. I know it sounds like a product advertised in infomercials, but it's not. It's a method. So let me show you then how I took care of this. The GameCube can be opened by removing the screws from the bottom. But in order to do that, you need a special Nintendo screwdriver. After freeing this little front panel, I simply put it in highly concentrated washing fluid for a day or two, simply to get the surface really clean, and I just let that sit for 2 days. In the meantime, I clean the dust from the inside with a compressor, and I try to dust off the optics using pressurized air from a can. But be careful, it gets really cold. And I also remove these little dust covers here. I carefully take the little springs aside and then put the doors also into the soapy water. And then I take the panel out of the water, and as you can see by the dark color of the fluid, it did help a little bit, but the panel of course is still atrocious. And here is what we need to change that. This is 12% hydrogen peroxide, usually used in hair salons. I place it into this lunchbox here and submerge the parts inside the fluid. I do not apply any light or anything else and just let it sit for a day. And this is what the parts look like after rinsing them off. Not perfect yet, but there is an improvement. Now I again apply the solution to the parts, but this time I wrap them in plastic wrap and put them outside in direct sunlight. It was a really hot day with over 30 degrees Celsius and almost no clouds. And I let the parts just sit there for 1 or 2 hours. And this is what it looks like after washing them off and letting them dry. Well, but that was only a first test of this method, and I have a much bigger restoration project that I'm using it on right now, and I'll show you the results soon. So I hope that you liked this video, and in that case, please give it a thumbs up because I really need the feedback here. And if you want to support me in making more videos, then support the channel by making a donation or becoming a supporter on patreon.com/tpai. See you soon, guys.